takes a little bit of work. We're going to be using this formula right here. So we want to express the complex number using polar coordinates. All right. And so what we're going to do here is we're going to go ahead and we're going to graph this point. So this says go to the left, so this is in rectangular right now. So I'm going to go to the left 3, so this is a distance of 3, and then I'm going to go up 3, 1, 2, 3. Okay, so real quick, notice right now that I have a special triangle. Now how do I know this? I know that I have a special triangle because the lengths of the legs are exactly the same. Now, even if you didn't catch that, there's other ways that we could do this. So I'd like you to do me a favor right now. Come off to the side, because maybe with the stress of taking the test, you happen to forget about this. So please put A and A. This is 45 degrees. This is 45. Obviously, we can see this is 90. And this is A square roots of 2. So whatever is A is, we know that the hypotenuse of the right triangle is just the leg times the square root of 2, the length of the leg. So again, I did not put a negative sign because the negative sign just said the direction. It told me the direction in which to move. So horizontally to the left 3 and then up 3. And here is my point. What if you forgot about this? What if you didn't realize this? Well, then you'd go A squared plus B squared equals C squared. Okay, so 3 squared is 9 and 9 equals C squared. 18 equals this, and then you'd have to take the square root of that, but then you have to break it apart. So we know that 9 times 2 equals C. We're only talking about a length here, so that's not plus or minus, it's just plus. And that's how we get 3 squared to 2. Or you may have been one of the lucky ones that sees this. It's also something you're going to write down on your test, those two special triangles. And you can see the lengths are 3. So A is 3, and then this would always be 3 square roots of 2. Okay, this is the formula you've got to memorize. We have several things in the next month that we have to memorize. So when we look at this, we know that our R is this distance, right? Our R is this distance, and so R is this length, just like we've been learning. So R is 3 square roots of 2, and then theta represents our angle. So theta represents the angle. So to get here, because this is 45, I know this is a 45 degrees. How did I know that again? These are the exact same length. So if this is 45, that means this is 45 because this creates a right triangle. So I want to know what is 90 plus 45. That's 135, which is equivalent to 3 pi over 4. So 3 pi over 4. Now we're just going to come back up here. R, so I need 3 square roots of 2. So 3 square roots of 2, that could be it. Nope. That could be it. Nope. Then I want cosine of 3 square roots of 4. Cosine, oh, that's not it. 3 square roots of 4. Let's just make sure. There's our I, there's our R again, and then the sine of 3 square roots of 4.